Alright, looking at this circuit, this is what we worked on in class. You're going to go to the most complex parts of the circuit first, which would be the 6 ohm resistor and 6 ohm resistor in parallel, and the 4 ohm resistor and the 12 ohm resistor in parallel. So to figure out the equivalent resistance of those two parts, alright, we would have 1 over 6 plus 1 over 6 is equal to 2 over 6 is equal to the equivalent resistance of that part, where R in this case would equal 3 ohms. Alright, if we look at the 4 ohm resistor and the 12 ohm resistor in parallel, we would have 3 over 12 plus 1 over 12. That would equal 4 over 12, which is equal to 1 over R. So R again will be 3 ohms. So we're going to simplify this whole circuit all the way down so we have one resistor. Then we're going to work backwards and figure out the current and the voltage across every single resistor in the circuit. So just so you guys know, we focused on in the first part this here and these over here. Now to redraw the circuit. Okay, I added a couple features here to save some space. The first thing I added were these two dots. This is just indicating that I'm still accounting for the 18 volts here, but to save the space, all I did was not include it in this picture. So we have this two 6 ohm resistors, which becomes a 3 ohm resistor, and the 4 and the 12, which also become a 3 ohm resistor. So looking at this, we have the two 3 ohms are in series, but these two combined are in parallel with the 3 and the 2, which by themselves, the 3 and the 2 are in series, but these two together are parallel with the two 3s on top. So the equivalent resistance for the two 3s on top would be 3 ohms plus 3 ohms. This would be 6 ohms. And the equivalent resistance for the branch on the bottom would be 5 ohms. And that came from the 3 ohms plus the 2 ohms. Alright, after redrawing this, we then have the 6 and the 5 ohm resistor in parallel. So this would be 1 over 6 plus 1 over 5. The common denominator here is going to be 30. So this will be 5 over 30 plus 6 over 30. That will give us 11 over 30 is equal to 1 over the equivalent resistance. The equivalent resistance will be 30 divided by 11, or 2.72 ohms. I can redraw this one last time. Alright, so what I added to the screen was as follows. Alright, we redrew the 6 and the 5 ohm resistor to the 2.72 ohm equivalent resistance. Then I simplified this into a series and added back the 18 volt battery, so I could then calculate the current, which would be 18 volts divided by 5.72 ohms, and that will be 3.14 amps. Alright, now we can work backwards. Okay, so the 3.14 amps is going to travel through the 5.72 ohm resistor, which means it's also going to travel across and through, I should say, the 3 ohm resistor and the 2.72 ohm resistor. Okay, so if we look at this, we can figure out the voltage because we know the current and the resistance. So the change in voltage times the current, or the change in voltage is equal to current times the resistance. So for the 3 ohm resistor, it's going to be 3.14 amps times 3 ohms, which will equal about 9.42 volts. Alright, if we repeat that then for the 2.72 ohm resistor, since they are in series, they will both have the same current. This would be 8.54 volts. Alright, if we add these two together, these equal approximately 18 volts. So far we're checking this, we're in pretty good shape, which means the 3 ohm resistor going all the way up through the rest of the circuit is going to have 9.42 volts, and the 2.72 ohm resistor will have 8.54 volts. Alright, so now if we look at this 2.72 ohm resistor really represents the 6 ohm and the 5 ohm resistors in parallel, which means if 8.54 volts are across the 2.72 resistor, that means the 8.54 volts will be across both the 6 ohm and the 5 ohm resistor. So if we know the voltage and the resistance for each of these, we can find the current across these two branches. And the current going into here is 3.14 amps. So these two currents should add up to equal 3.14. So we come over here, we look at Ohm's law, we have delta V over R is equal to the current. We have 8.54 volts divided by 6 ohms, and 8.54 volts divided by 5 ohms. All right, if we make those calculations, we find out that this would be 1.42 amps and 1.71 amps. If you add them up, they equal approximately 3.14 amps, even though it's 3.13. So we're still in pretty good shape. All right, continuing on. All right, so the 6 ohm resistor really represents the two 3s in series. So the current traveling across this is 1.42 amps. And the 5 ohm resistor really represents the 3 and 2 in series, and the current across that is 1.71 amps. So what we are going to do here is, we know that across both the top and the bottom there are 8.54 volts, which means that the two voltages across the 3 should add up to equal 8.54, and the voltages across the 3 and the 2 should add up to equal 8.54. So we're going to come over here and we're going to calculate the voltages. Alright, so the voltage will equal I times R, and for the top two we'll have 1.42 amps times 3 ohms. This will equal 4.26 volts, and since there's two of them, that's approximately 8.5 volts, so we're okay across the top. And then across the bottom, you're going to have 1.71 amps times 2 ohms and 1.71 amps times 3 ohms. Okay, if we make those two calculations, we find out that we will have 5.13 volts and, oh wait, that's for the wrong one. Sorry, you'll have 3.42 volts and 5.13 volts. Again, these add up to be about 8.5 volts. So looking at this, components in series should add up to equal to 8.54. They do here, and they do across the top. Now we can continue on looking at the 3 ohm resistor here, which has 5.13 volts, and the 3 ohm resistor up top, which has 4.26 volts. So now we're going to come back to our red circles up here. For the 12 and the 4 ohm resistor, we are going to have 5.13 volts across each, and for the 2 6s, we will have 4.26 volts each. Alright, now to figure out the current for each of these, for the 6 ohm resistors, it's going to be 4.26 volts divided by 6 ohms. You guys calculate 4.26 volts divided by 6 ohms would be 0.71 amps. And then we go to, so 0.71 amps go across the top and the bottom. If they combine and reconstitute themselves either before or after, it will equal the 1.42 amps where it came from. So this checks out. So we just have the 4 and the 12 to deal with. 5.13 volts divided by 4 ohms, and then 5.13 volts divided by 12 ohms. Alright, so now we have, for the 4 ohm, we have 1.28 amps, and then we have 0.42 amps. So if you guys look at these two combined would be about 1.7, which if you come check down where the 3 ohm resistor was and the 5.13 volts, you have 1.7 amps, 1.71 amps going into it and passing through it, which means this checks out as it divides up and then reconstitutes itself on the other side. Alright, there she is in all its glory. Yeah, that's it.